My name is Alan Grosvenor, and I am the CEO and founder of MsBay. We make it possible for you to set up simulations in minutes, not hours. The reason that we started developing our system that we call Guru is that simulation is a pain. The interface to a broad range of simulation packages look something like this, and that's the reason that she's holding her forehead. She has a PhD in aerospace physics, and yet she needs to navigate through all of these different options in that interface, and it makes it very painful and very time-consuming. Now, because simulation software interfaces are usually like this, it makes the whole process slow, and it ends up meaning that simulation software is highly underutilized. Only about 1% of engineers are using simulation software, and it's mostly because it's just too cumbersome and time-consuming. Today we have a wealth of affordable compute, particularly in commercial cloud systems, but it's not being used to solve some of the most important questions. So we developed Guru to make utilization of simulation software 100%. And we're going to show you what that looks like today. We're going to start off by showing you a live demo. My colleague Dustin is about to start up, I think, a CFD simulation. He's going to run a simulation of an F-35 flying at angle of attack today. He's just started up CFD. He's chosen an F-35 model. And now Guru is saying, okay, what are the flight conditions you'd like to fly today? Dustin, in this very easy to use spider chart, is going to select an appreciable forward speed and some moderate angle of attack, and then he's going to hit go, and Guru's going to take over the rest. Guru is setting up configuration files, then it's going to generate a computational grid, it is going to then batch off the CFD simulation, and it's going to post-process it. That takes a couple minutes to run, so why don't we jump over and do another entirely other simulation demo, also live at the same time. Dustin, why don't we run some trajectories today? So Dustin selected trajectories, and in this demo, we're actually running two different packages from vendors that are also on this exhibit floor today. We are using SAIC's Avatar trajectory simulation software and Cesium for globe visualization. Dustin is selecting a high L/D hypersonic glide vehicle for our trajectories today, and he's going to select some launch and aim points flying from San Francisco to Washington, D.C. You see the visualization of the launch and aim points across country in the globe view here. And then Dustin's going to select some maneuvers to include in his trajectories. Dustin has selected a left turn, a right turn, yaw oscillations, and a fishhook dive at the end. Okay? And then, just like the CFD demo, it's brought up a simple, easy-to-use spider chart with just the variables Dustin selected that he wants to set. So in the CFD demo, Dustin was selecting just flight components. So he just had 3 directions of flight. In this case, he selected a number of different maneuvers. So the spider chart's giving him the option to set the duration and acceleration in those maneuvers. You're seeing on the left-hand side the relative duration of the total trajectory that each of those maneuvers is going to take, updating as he makes those settings. And now Dustin has just hit the auto-populate button because today, it's kind of boring to run just one simulation. Let's run 60 simultaneously. What auto-populate does is it creates a Latin hypercube space-filling distribution of trajectories around the baseline settings he's just chosen. So we're going to run a threat space of trajectories today. And Dustin's hitting submit. Now Guru is setting up those trajectories, batching them off, and running them as well. So Dustin, if you don't mind, I'm going to take back over and show some more slides while those two simulations are running, and you'll signal me when you're ready to show us what it's doing. So we architected Guru to make it possible to set up simulations in minutes, something that usually takes people at least hours of manual laborious time. We wanted to make the experience really fun and very productive and functional for the user. So we started by making a user interface that's flexible and easy to use and portable so that it runs on your device. If you're on a Windows 10 desktop, it'll run there. If you're on a MacBook Pro, it'll run there. If you're in Linux, it'll run there. Also, it'll run on your mobile device. It runs on iOS, like the tablet over there. Now, on the back end, something very important to do when you're running a broad range of simulation software is you have to guarantee the environment that simulation package needs is what is going to be deployed. Our back-end orchestration system does that, and it enables us to deploy jobs to commercial cloud systems, on-prem systems, government systems, including air-gapped systems. And the central part in these layers is the hierarchical procedural AI system that I'm going to tell you a little bit more about. How are we doing, Dustin? We're getting close. Well, the hierarchical learning system that Guru uses that enables it to learn how to use SAIC software, Cesium, and many others is that we use a reinforcement learning driven hierarchy of symbolic AI and machine learning. So we're going to show you the layers that go from initial autonomous generation of data to train the system to where we turn on the reinforcement learning system and learn end-to-end workflows. But first, let's jump over to Dustin and see the results of his simulations. So we have trajectory results that were just generated. And on the left-hand side of the screen, you're seeing a clustered view of all the trajectories that were just run. So that's a nice overview way to review a large number of simulations when you run large data sets like this threat space set of trajectories. You have variables in those clusters that show you values for acceleration, pitch angles, durations, and that enables you to select a subset of the trajectories like Dustin has done and plot 3D range plots in both the range plot view as well as in the full up globe view in Cesium, and also generate trajectory reduced data and 2D plots that Guru automatically generates for you, and it gives you a lot of flexible options to generate exactly the types of plots that you want to look at. So Dustin's toggling through here. He's been showing us what the globe view looks like so that we can actually look at the final trajectories on the globe. And there are so many different options that Guru gives the user and makes it extraordinarily easy to just set up, run the simulations, and then view exactly what you want to know about those results. So Dustin, how are we doing on the CFD? Should we wait a little bit longer on that one? Okay, so it looks like we're getting close. Dustin, I'm going to show one more slide before we cut back to you, and then we'll look at some visualization. And I'm just going to show you that the way we start training this system, if you have a graphical user interface, our system automatically scans a graphical user interface and looks at every possible option and cascade of options that come from individual selections and populates it into a navigation graph. And this ends up being a very large number of instructions that are populated into this graph. Once that graph is populated, you can render it so that you look at the actual screenshots of the individual selections. And that's what it looks like when we've scanned an entire graphical user interface into a graph. And we do the exact same thing with the configuration files. So we're able to read in an entire corpus of configuration files, template files, user documentation, and all of those different language instructions are populated into a graph that gives the connection between all of those different types of instructions. Once we've done that, we use generative pre-trained transformers to start training language models so that they gain an understanding of the meaning of variable names in those configuration files. Ultimately, that gives the system a way to autonomously navigate your software, whether it's a graphical user interface or it's a configuration file. The system knows the connection between all of the different types of commands. And that enables the system to then monitor human expert users and learn from them. And it needs just a small number of those sessions because it has this foundation of learning that it's already built up from the primitives data, which enables it to navigate a new software instance based on a brand new user request and perform the studies it needs. And that's exactly what Dustin has just seen Guru doing for this F-35 model. So Guru just opened up ParaView, opened up the brand new CFD simulation result from what it just ran for Dustin, provided some 2D plots of surface values of static pressure, and then a 3D view of streamlines over the vehicle. And now Guru has handed over control for Dustin to go in and probe and take a closer look at those results. Nice job, Dustin. Nice job, Guru. Everyone, my name is Alan Grosvenor. I am the CEO and founder of MISBay, and we developed Guru. The purpose of Guru is to reduce the time that it takes for you to set up a new simulation down to minutes, something that used to take hours. Thank you so much.